Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com Roundtable, brought to you by Techstrong. My name is Cody J. Brown, the host of Techstrong Learning, and we have an exciting panel ahead. First, I need to cover just a couple of housekeeping notes. Today's roundtable is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab on the right side of your screen. That's also where you'll find a couple more tabs. There's the chat tab, and we want you to use that for more general discussion. Let us know your thoughts throughout today's program, maybe where you're tuning in from, or what your position is in your organization. We've also got a couple of handouts available under the Handouts tab, so feel free to grab those. There should be about 4 of them. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's conversation. So our topic today is DevSecOps, and I'm joined by Natasha Gupta, Senior Product Marketing Manager at Synopsys, Jack Marsal, Senior Director of Product Marketing at Mend, Sid Chaudhary, VP of Product at Harness, Kiran Committee, Founder and CEO of DeepFactor, and kicking off our conversation today is Mike Vizard, Chief Content Officer here at Techstrong Group. So thank you to everyone for joining us on this panel today. Mike, do you want to go ahead and get this first question going?
All right, great. Thanks, Cody. Hey, guys. As we all know, DevOps in itself is a journey. No two companies are in the same spot in that journey, and DevSecOps is pretty much not much different. Everybody's all over the place. But we have noticed that as we go along, there's more mature processes in place. So I want to throw the first question out to Kiran, but are we starting to see some advantages in terms of how we think about DevSecOps, and are more people down the path? Because we're starting to see things like security engineers starting to show up in these DevOps teams, and it's kind of like the equivalent of a site reliability engineer just for security. I don't know how many companies have that, but it's the beginning of a trend. So are we making progress?
Yeah, absolutely, Mike. We're definitely seeing changes in how people are thinking about it. 3 years ago, when we started DeepFactor, it was all about, there was a lot of evangelization around the need for DevSecOps and the necessity to have security early on in your development and testing lifecycle. Now it has changed. I think people understand that they want to do it, and it's about the how right now. And the how can be both in terms of, do I use the right tooling? Do I have the right team structure in place, so on and so forth. So definitely we're seeing maturity, and we are seeing security engineers kind of being matrixed into DevOps organizations as well to make this happen also.
So Sid, do you think that we're, at the end of the beginning of DevSecOps then, or somewhere in the middle of this, or is it still like very, very early on and people are still learning, what the term means?
I would say I think we're somewhere in the middle, right? Like Kiran said, a few years back, it was about making sure that everything that you push to prod is getting tested, scanned. Unfortunately, those things were not happening closer to the developers, and developers were getting, I would say, security issues as Jira tickets, and they were getting frustrated. We are in the middle part where shift left security testing in as part of the software delivery process, and the CI/CD pipeline is starting to become the norm, and developers are able to collaborate with that security engineer persona, which increasingly organizations are hiring, and then ensure that new security vulnerabilities or known security vulnerabilities are not necessarily showing up. And then I'm sure we'll talk about the future where supply chain security, with clear understanding of what goes into my software from an open source component standpoint, so that I'm ready for that all critical 0-day vulnerability that will show up any day, and I have to react to it, right? So we're in this journey somewhere in the middle.
All right.
If I can jump in, I agree with you, Sid. We're in the middle. The first stage was just the recognition that we have to shift testing earlier, because the developers are now responsible for finding and fixing the vulnerabilities. But the first efforts really were not all that successful. Yes, tools could now be triggered earlier, but if you actually survey developers, and you ask them, how often do you knowingly release vulnerable code? Huge percentages, like 80%, say, yes, I do that all the time because I can't be bothered with the security tools. So we haven't, as an industry, really solved that problem. And I think we're just now beginning to see tools that are actually built for developers. I guess ship secure software faster is really the goal. And to have tools that developers want to use that's sort of invisible because it's a sort of a natural part of their existing workflow, that's sort of the new bar I think that the industry is trying to get to really achieve results.
Natasha, do you see the same thing? And I'm asking the question because a lot of developers I know never got anywhere near a security class when they were in college or training. It was an elective somewhere. And I think, I'd be safe to say maybe 2% of them took that and probably only took it because they couldn't get into some other course. So are the developers becoming more amenable to this shift left, or are we like shifting left and they're like going, excuse me, but you didn't ask me if I'm on board for this program?
Well, I certainly think it's a culture shift. It's a mindset shift. And the essence of it being that secure code is quality code. And the reality is that the developer persona is so central to rethinking how we look at business risk today, because the truth is that the pandemic in a lot of ways was an accelerator for trends that we were already starting to see in the industry. If you weren't doing DevOps earlier to push product out faster, to be able to keep your services highly available and resilient, well, you started doing it right during the pandemic, and DevSecOps had to follow suit. A lot of what we have thought of in building security is a very reactive model. And when you think of infrastructure vulnerabilities, for example, now that could span maybe hundreds of assets across your IT estate. But when we take it in a software context, now you're talking about thousands of commits per day for custom built code. And so when we think about the responsibility that the developer is so uniquely positioned in their context of how do certain parts work with others? How do certain dependencies in my software get affected if a fix is committed and it breaks something else? That has really highlighted that whether or not there is a willingness to adopt security, the developer is going to be so central to how we think of developing successful DevSecOps that is catered to their individual experience.
All right. As part of that, Sid, I want to throw this next question to you because we talk about shift left as if, if we put everything over to the developers there, everything will just be grand and fine. It seems to me that, they're focused on their code. And then we have this little thing called the DevOps workflow and all this stuff shows up in a build somewhere. But who's keeping track of who's contributing to the build? Because someone could insert malware into that process as well. So do we kind of need to simultaneously shift left to developers, but then lean a little bit more left towards the DevOps platform? And we need to kind of think about this on a more end-to-end basis.
Exactly, Mike. That's our point of view at Harness. We see that all the time, that the developers have all these sort of rich variety of tooling, but trying to, make sense out of that from a known vulnerability management part is the first side of the problem. So that's where sophisticated, deduping, normalization, and showing exactly the line of code and the recommendations that can actually remove the vulnerability becomes important. But parallelly, they have to also be educated that there will be future risks that come in by us consuming probably 95% of our code base being open source. So we need to bake in concepts like SBOM generation, looking at deny list of open source libraries, looking at allowed lists of open source package managers, identifying typo squatted malware just that may have just showed up right inside the pipeline, so that they get increasingly aware and they feel good about it, that they have made their own life easier, because these things never will show up later and come back to them as like massive escalations drop everything, all features, and just focus on this. No developer wants to do that.
Yeah. I want to really pick up on one thing Sid was mentioning here about really going after these open source dependencies and a lot of that shift towards shifting that testing downstream. Something we have seen for a lot of customers is the dependency on integrated developer environments, IDEs, in being able to swiftly develop code faster. And one of the aspects of being able to do IDE-based testing, to be able to catch this a lot earlier, is also coming back to Mike, a lot of what you were talking about in making up for the knowledge gap of security knowledge with your development teams and developing that notion around and that culture around how to really develop better secure coding practices. And actually, we've seen this with a lot of our customers at Synopsys, that the first step often into taking that plunge into developing successful DevSecOps is moving some of that testing into the IDE to really tackle at the outset, if you've got open source code that is out of perhaps date with the software version that is required to tackle open and known vulnerabilities, being able to get insight into that earlier rather than costly post-production fixes.
Okay. Karen, what will be the role of the cybersecurity folks going forward? And I'm asking the question because it's not uncommon for the following scenario to occur. Developer A will download some sort of insecure component from some repository somewhere. It'll show up in an application. Security people will discover it, send them a note, ask them to update it. And then developer B will go to the same repository, download the same component, shove it in a different application, and the same vulnerability will be discovered again by a different developer. And then developer A will go back and update their application and download the same insecure component and basically wipe out the component that had already been remediated before. And it becomes this vicious cycle. And, the security people are naturally tearing their hair out. So how do we have a meaningful adult conversation about this and in a way that doesn't make everybody feel like, I hate that guy?
Yeah. I mean, at the end of the day, it's the way I see it is there's three personas involved: security, DevOps, and developers. The number of devs, when I say devs, I include both developers and QA, right? That number together is significantly higher than the number of DevOps or the number of security people. So the job of the security person should be, am I putting the right guardrails in place and the right tooling in place so that I have the maximum possible security? And the job of the DevOps person working in conjunction with the security person should be, am I putting all of these tooling in the right places where my devs interact with? Starting all the way from the IDE, as Natasha mentioned, to the CI/CD pipeline, which is what Sid, specializes in, to the runtime, all the way from in your dev cluster, test cluster, all the way through to your production cluster. So there's a bunch of these connectors that you've got to establish, and at each point of connection in the developer's journey, there has to be automated warnings that pop up that say, you've done something that is a security risk. You've got to go fix. Now, from a developer's perspective, the win here is developers at the end of the day want to ship secure code. They just want two things. They want to be told what security risks are earlier in the development journey as opposed to the day before the release. Number two, they want to be told that there's an issue, not that there are 200 issues, right? So tell them what is important, tell them early. And the security person's job is to make sure that that happens with the right tooling. And the DevOps person's job is to implement the tooling and the right connection touchpoints.
Yeah, the issue of alert overload comes up here. And I mentioned before that the initial move to just do testing earlier really was not enough. If it's done wrong, you're showing every developer every bug in the entire application. Any individual developer just wants to know, what did he do wrong in the last hour or the last day? And so the better tools will just give you an incremental view or just a feature branch that a developer is working on, and give him feedback or her feedback. Did you make an improvement, or did you introduce a new bug? So
as part of that conversation, can we get to the point where the developer is kind of getting what it sounds like almost, I'll call it a danger Will Robinson feature, where it says, if you do this, you're going to have a bad experience, and, likely you're going to be fixing this again in about, 3 months down the road. And I guess the issue in my mind, and maybe Natasha, you can jump in here, it seems like we're asking developers to fix things so long after the fact that they've lost context as to what it is they were building when they were originally building it. So as part of our issue here is that we're just not in the moment. We're just not giving these people the feedback loop when it matters to them.
Definitely, Mike. And I really would second that. It's important that when you are starting your DevSecOps journey, you have to be very cognizant of the existing environment of tooling, feedback systems that your development team is using, and make sure that how you orchestrate a very successful framework of security tools and practices around that is very much integrated with how a lot of this feedback gets passed down to the developer. Something that we often talk about at Synopsys is the concept of ASOC, Application Security Orchestration Correlation, and being able to have a central point of being able to interface with developers directly by streaming down all of that data across a lot of this rich tooling and scanning that you're doing, and being able to prioritize the most critical work, push it straight to Jira, ServiceNow, or whatever ticketing system your development team is using. I'd also like to highlight another important aspect of this, that the developer's experience being able to be meshed with the way that you do security is a very important component of making your security program scalable. I think we've often putted around this term that, well, developers are just simply going to have to accept that security is part of their job, and that we almost had a certain level of acceptance of that risk tolerance if we cannot successfully integrate certain level of security tooling. And I think we have to scratch that and do away with this approach. Really start thinking about how well integrated your security approach is meshing with how your developers interact with the tooling that you've integrated day to day.
So we have one question already from the audience. I'm going to throw it towards Sid, because it goes to the heart of the matter, right? Some people would say, or have questioned, are we building software that is unsafe at any speed, to quote Ralph Nader from back in the day? But the question is can we accomplish the building of more secure applications, or do we have to slow down the rate at which we are building these applications to achieve that goal? Or is there a smarter way to think about the way we're building them to embed security into the quality process, and so we don't have to sacrifice speed for security? What's your thought?
Yeah, absolutely. I think modern tooling has to focus on making all of these happen exactly at the same time. There is no either or option here. So today, from a developer standpoint, when I start coding, right, I have so many things in my mind. I'm thinking about functionality. I'm thinking about performance. I'm thinking about scalability. It's sort of natural to also bring in security into that with the right education and the right tooling, right? And make sure that they understand the sort of the impact of their actions in this kind of a setup. And that coaching, most likely it's an organizational culture change, right? As Kiran mentioned, these three personas have to work so hand in hand that initially the security team will have to help the DevOps and the dev team to understand this culture change and importance. And then as the software, let's say, gets designed, we have like functional reviews, right? We have testing, test plan reviews. Similarly, the security team would like to get involved in the reviews of how are we gonna make sure that this software is secure, and through the complete chain, starting exactly from IDE to all the way till prod. So we are, I would say, making great strides at this, especially with the two hacks. I would say SolarWinds and then Log4j. I think previously it was a nice to have or like important thing to have, and you can just push code if you don't think that I'm just going to get there. But nowadays, especially in the regulated enterprise, we see that people are willing to say that, okay, we are going to give you all the tooling beforehand so that you prepare. But at the same time, towards the end, if we see that none of those approaches have been followed, then we are okay to ask you to stop and fix and course correct, because the cost from a reputation and sort of market risk is way too high for us.
Jack, do you think that we'll ever get to the point, or maybe we already have them and we just don't know how to use them, is that we're going to have templates and people can just follow along, and we're going to try to make this a little more, shall we say, idiot proof?
Templates. Never heard that suggestion before. Don't think so. The closest thing that I can think of is a private repository where you've screened the open source software and the other packages that you're going to allow your developers to use. That's very popular. Artifactory is probably the leading repository. And to have some sort of pre-filtering, for example, the ability to ensure that malicious open source doesn't somehow get into your repository. That's a very important aspect. I believe I saw the statistics that malicious attacks on the supply chain have increased 650% in the last year. I think someone mentioned dependency confusion. Is that the name of the way that an open source package is going to be maliciously injected, where before you were using a good one, and all of a sudden you say, oh, I'm going to update to version 803, which is actually a malicious one. So you need to prevent those. That's the closest thing I can come to for being a template. Maybe someone else has another answer.
Yeah, I think maybe a different word to consider here is policy. It's at least that's the word that I see being used, whether you use something like an OPA or even otherwise. A policy that serves as the common basis for setting the guardrails between the AppSec team and the developers is probably a way to think about it, because AppSec team or ProdSec team establishes the policy, which essentially serves as the guardrails and essentially like a rail track that the developers can't deviate from. And those policies could be different for different organizations. For example, in some organizations, you could say, if there is just focusing specifically on dependencies, if there is a dependency with a CVSS, with a CVE that has a CVSS score of 8 or more, then you cannot ship the product. That's the policy that the AppSec team kind of can establish. And if the dev kind of deviates from that policy, they will know that early on during development so that they can fix it, and otherwise the release is not shipping.
So at just a quick note, at Harness, what we see a lot of our customers doing is create this golden paths to production through all kinds of templates that you are talking about. There is a build pipeline template around what sort of security reliability testing I want to do. There is a deployment template on what should I do in pre-prod testing, and then how should I roll out into production. What sort of checks I should need to make sure that it has gone through, like using OPA policies and so on. That's overall part of the golden path to production. And the combination of these, like the DevOps and sec teams, and in collaboration with, I would say, engineering management, comes up with this. And then the developers have a sort of a more smoother ride, because they are not being asked to constantly be firefight and change some processes and caught off guard.
We're having a lot of questions starting to pop in from the audience, but part of this comes into this next question is, how do you prioritize what to fix? And I think one of you guys mentioned dependencies that exist, and some of those are direct and indirect. And not everybody seems to know what exactly should be fixed when. And so maybe, Jack, you're nodding your head. Is there some way to think about this where we can figure out, perhaps that alert storm that just came through is actually all related to one thing, and we should go fix that particular thing first?
Absolutely. The better security tools will do that. Fix this, and you'll fix nine other things. And another part of that is not to present the developer with a million false positives. That will be the kiss of death. Once the developer says 70%, or I don't know what the magic number is, more than too many of these alerts are false positives, the developer is not going to use that tool anymore. So you need to find some sort of a strategy to weed out the false positives. And the better products have different ways of doing that.
Natasha, are we at that point now? Can we basically say to folks, if you don't have a tool that's helping you figure out exactly what the dependencies are, maybe you need a new tool?
Well, a lot of it too comes back to something Kieran mentioned about being able to centrally manage and orchestrate policy. And one of the most scalable ways in which you're able to do that in the true essence of DevSecOps is being able to integrate policy well within your pipelines through managing it as code and being able to codify a lot of these parameters that Jack is alluding to here. Things like how critical is the data that this application handles? Is it a business critical application, first of all, that the vulnerability is found in? Parameters like, well, what is the severity of this vulnerability, or what is the type of tool that I should be using for scanning this particular software? What exactly are the conditions for even triggering testing to begin with? And importantly, what policy also enables you to do in your earlier question of templatizing that process and prioritizing the most important work is that we're reckoning with the reality of how software development is done today and standardizing our security hygiene across. When you have large organizations that we talk to where they are contracting code with the Wipros and the third party, software contractors of the world to be able to develop software faster. And all of these different sources of developing code, they don't necessarily have the same security tooling or the same security practices across. So how do you get around that? Well, instituting those policies as code, being able to centrally manage how you orchestrate security policy across. I think that's going to be a very big part of prioritizing the right developer work and being able to successfully institute a consistent security culture and security practice across however you develop software today in your organization.
Kieran, is it easier to have this conversation lately? If I go back in time, 2 or 3 years ago, I felt it was like, a niche within a niche of people who were talking about this. Then suddenly the president issues an executive order and suddenly everybody and his brother's talking about it. So, is it simpler now to, bring this subject up and have people kind of buy into the whole concept?
Oh, it definitely is. Joe Biden's executive order was it made it kind of open to more people. However, if you purely look at the executive order, it still applies to companies that are selling products into the Fed. But generally speaking, that coupled with some of the high-profile attacks that have happened have definitely opened, SolarWinds, and we had a ransomware thing with Colonial Pipeline last year. So all of that, these things are adding up. So people want to get in the habit of creating secure code. I do have a point to add, Mike, about the previous question that you asked, which is when do you decide to stop? Right? Is it the same for everybody, every type of security vulnerability or not? So one point that I wanted to add to what Natasha mentioned was that when you think about setting policies, policy is not like it's different for different types of threats that your application may face. So at DFactor, for example, we think about cloud native applications as having 4 layers. It's of potential attack vectors. Your code, your dependencies, stuff that goes into your container images, and the web interfaces that you've exposed. It's a 4-layer cake. And the rules that you set and the policies that you set are different for each of the types of risks that each of the 4 layers of cake can have. So.
Mike, you're on mute. Mike, you're on mute.
Sorry about that. We're trying to limit some feedback loop there. Let me ask you this question from this perspective. We're very focused on developers and what they can do and the shifting left, and yet we do see things like the log4j shell vulnerability suddenly shows up out of nowhere. We've got this kind of 0-day vulnerability. Everybody hits the fire alarm and everybody rushes to the office to try to go fix this thing. But do we really have the processes in place to deal with those kinds of incidents? I know some people are still looking today for where that malware might be in their organization or where the vulnerabilities are. Do we need better processes for discovering stuff after we deploy it? We talk about S-bombs, but I haven't heard anybody really explain how to operationalize an S-bomb. So what do we need to do and how should we think about it?
Yeah, we are starting to do this at Harness, Mike. So the way our customers are sort of speaking to us is that there are two forms. One is known vulnerability management, right? All the stuff that we have talked thus far, and making sure that we're introducing no new known vulnerabilities and burning down the existing ones. The second aspect is about being prepared to understand and mitigate risk of unknown. Essentially risk of unknown open source components, which can be 0-day vulnerabilities, license compliance risk, or the open source project just going away and no longer being maintained. So for that, along with your security testing, you have to start generating S-bombs right at as early as possible, and then from those S-bombs, you start defining what is an right. Like imagine a score for an S-bomb, like how comprehensive that S-bomb is, how correct that S-bomb is, and what sort of policies you want to attach as to what libraries are allowed, what libraries are not allowed. And then every time you touch an artifact, you look at its S-bomb, you verify its signatures, you make sure that everything is okay to move forward to the next stage. And then obviously you will go to prod with this two-pronged strategy of known and unknown. And now the next log4j shows up. All you need is go back to your interface and search for that that newly vulnerable library and identify exactly which all environments that particular library is present in, whether it be your prod environment, whether it be a pre-prod environment about to go to prod, or your build environment, right? All of those are possible. And now you just click on a button and start remediating literally in every one of those environments, step by step, and allow the security team to be completely in control with respect to tracking, so that like most likely, when you're doing a fix, the upstream has not been fixed yet. So you may have to go probably 2 versions back and just remediate it in the first 72 hours, as long as not you're breaking functionality, and then come back again after the upstream has been fixed with a proper fix, right? So that sort of trackability is what is desired out of tools, and we at Harness are like completely focused on getting those to our customers.
If I could,
yeah.
Go ahead, Natasha. You first.
So I just want to quickly add, Mike, that I think a lot of where the question of S-bombs and a lot of the interest in that is going is we've seen a fundamental paradigm shift in how we think of risk management and how we look at mapping the actual environment of where your business risk lies. And I just wanted to add to one point that Sid was bringing up about mapping out an S-bomb and practices around that what you're ultimately aiming at doing here is building out your software asset inventory. A lot of times when we talk about CMDBs, when we talk about mapping out what your business risk looks like in terms of what are your assets that are business critical and the relationship and the stakeholders that control them, is we've often talked of that in an infrastructure context, but I think that growingly the consensus is when we look at open APIs, or we look at sources of where your software is developed and what are the components that make that up, we're starting to awaken to the concept of building out that software asset inventory and understanding the developers responsible for it, the business criticality of it, and what exactly is the impact of a vulnerability found that affects it. And I think that that's a very critical piece of why the executive order is effectively becoming a de facto standard for so many organizations today in evaluating how they are accredited as an organization that has secure software development practices, that can be a trusted vendor in their space. And I think that we're going to have to see more of how SBOMs really redefine the nature of how we look at risk management as a traditionally branching beyond the IT specific context and taking it further into the software specific context.
Yeah. Jack, you want to add to that?
I do. That was a great question. And the answer is yes. Now, what was the question? Oh, yeah. The question is, can you really deal quickly and easily with events like Log4j? The answer is yes, if you're prepared. And gets back to what Natasha said. It's all about the inventory. If you have an inventory already in place for everything that your company is doing, then it's just another normal day when Log4j gets announced. You simply go through the inventory and you find where your vulnerabilities are. So I think the word here is complete. If you have a complete inventory, many times companies will come to us and they say, we have some critical projects that we need to start to secure. And so if you've only deployed your DevSecOps tools to those critical projects, and then Log4j gets announced, then what percentage is unknown? So it's really important to have that complete inventory and complete deployment. And here I would maybe take a little bit of a different tack than Natasha was saying, how important IDE integrations are. They're good, but they tend to be non-comprehensive. It's difficult or impossible to centrally manage the deployment of and centrally manage an inventory if the only thing you're relying on is an IDE integration. So perhaps think about integrating with your repos or integrating with your pipeline, with your build pipeline as well.
So Natasha, help me out here, because there's things that I don't understand about this whole thing. And part of it comes down to, so we're shifting to these cloud native applications and we're ripping and replacing containers. So how do I know what's in the application and how does the SBOM keep pace with that? And then meanwhile, I've got a bunch of microservices on the other end that somebody else updated, and I had all these dependencies on that and they changed all their components. And this is going on, you know, several times a week. So how do I keep track with all that?
Well, I would say that it comes back to actually an important point Jack was making, which is that you can't rely on one single method of testing. And you're absolutely right, Jack. I think you have to spread out different types of testing for different components that you have to look at and different environments. So what my recommendation would be in terms of working backwards from looking at what kind of scanning data you're getting and being able to map out that picture for yourself is you have to think at every stage, what exactly are the kind of flaws I'm looking for and the right tool to be able to ascertain that. Certainly IDE testing is a good first foray into it if you're not practicing AppSec right now. But I would say that it's a combined approach of being able to conduct a certain level of IAST testing to be able to do testing in runtime. There is a certain component of being able to do build-based testing with a DAST solution. But regardless, to be able to centrally glean what exactly is the complete picture, it's very important to be able to correlate that data across many different types of testing that you may be doing, whether it's API-based testing, static testing, whatever you have in place, and even manual testing. There are a lot of organizations that will have those corner cases where you'll have to do manual code reviews, et cetera. But being able to centrally be able to glean that information, correlate it across, and have a standardized sense of being able to do risk assessment and prioritization. Because being able to centralize a lot of this across when you have so many different points of scanning, testing, control, environments, it's very important to standardize that level of risk judgment. And so that would be my recommendation. Have one interface, one central place that you can be able to communicate a lot of that rich data and make the most out of your AppSec investment, being able to make the most of what you already have in terms of resourcing tools and people.
All right. Jack, we have a question from the audience, and maybe you can help them with this, but the observation is we've had SBOMs for years, and we are starting to see SBOMs that are built on a JSON format. So is part of this issue now that SBOMs are just getting easier to share because they've changed the format of them, or what's going on?
Yeah. You asked, are we in the early stages, the middle, or the late stages? I think we're in the early stages of SBOM. We're at the stage that people know what they are and know that they need them. I think the industry has a long way to go in terms of processing SBOMs. Now that you have them, how do you use them? How do you ingest SBOMs and from multiple sources? So I think we have a long way to go still there.
Yeah, Mike, on that front, right? The standard bodies, like the Linux Foundation, for example, is doing with SPDX, or the OWASP Foundation doing it with Cyclone DX. Those are very important because that they give us a common language for all these SBOMs to be, become machine readable at the core of it. And then once they become machine readable, then you can use automation. You initially, obviously, you have to use automation to generate them and store them. And then as you're along with every phase of testing that Natasha was talking about, and also in prod, you have to also do an SBOM driven policy enforcement because it is machine readable. And an OPA policy can look into the contents of an SBOM and easily sort of identify that this particular library source from this particular library source is no longer okay.
So to that point, are we eventually going to get to the point where we're essentially playing, a big game of red light, green light, 1, 2, 3 with software, and we're going to look at the SBOM and say this can go forward or not go forward? Is that the goal, Sid, or where are we?
Yeah, I mean, it's we see the things that are obvious, we have to automate, right? And there will always be a need for some, I would say collaboration, because the space is evolving so fast. Like if a developer is not able to understand what to do with it, they should be able to click on a button and ask for help, right? Because it is better for a security engineer to help them in context, in the tooling that they are already used to, before just blindly saying that, okay, nobody has time to help the developer, and automation is the only way, and it'll show up, essentially that exposure is now okay in production, right? So our thinking is that we should automate all the manual toil that has been present over the years, but also allow for very in-context collaboration with all the three personas in this puzzle.
Kieran, how smart can the automation get? We hear a lot about AI every time we walk out the door these days. Will that eventually get applied to this? And, can algorithms save us from ourselves? Where are we going to be?
Yeah, I mean, AI is one part of the automation here, but there's plenty that can be automated around SBOMs. I think Sid mentioned some great points. With OWASP standardizing on Cyclone DX, Linux Foundation, and SPDX, I think we're basically given a format that suddenly becomes automatable, because machines can kind of understand, look at an SBOM and say, okay, this SBOM has my log4j, and new vulnerability just came out, or just last week, like OpenSSL, v30x, if you have that in your SBOM, then proactively, even without looking at your static container images or your running Kubernetes clusters, you'll be able to say, these are the places where I have the OpenSSL vulnerability, and these are the things that I need to patch. Then you can use OPA or other things to kind of set rules and say, if I have this, then don't run this in my production environment, or at least alert me so I can go back and tell my team to go fix that container image. I think there's a lot that can be possible. we're just beginning to scratch the surface of what's possible, because at this point as an industry, we're trying to figure out, oh, we just figured out the format. Now let's make sure that everybody kind of gets their SBOMs created. Once they create it and we have a database of SBOMs that is already lying in one data store, then you can apply automation on it to do a whole bunch of meaningful things going forward.
All right. Speaking of automation, Natasha, how automated can this code scanning process get? Because one of the issues you hear from people all the time is, they don't want the overhead. They will write a piece of code and then they'll be like, well, I'm not ready to run the scan yet. And then by the end of the week, they'll have this massive amount of code to scan, and then they'll complain about how slow it is. So is there best practices for scanning, or can the whole thing get more automated than it is today?
Absolutely. That is a huge barrier that we see too, of being able to apply a certain level of consistency of testing. It consumes a lot of compute. It can be redundant work. And again, I would come back to being able to codify and standardize in policy a lot of why are we doing this testing to begin with, and standardizing those conditions around testing. If, for example, you simply made the change to a font in the UI of your application, that's not a case that will require an additional round of static analysis in that case, right? But if you had something a little more critical to how your application functions, and something that would be critical to a application that handles perhaps sensitive PII data, that's a case where you would have to be able to automatically trigger that testing. And it comes back to a lot of what Sid was talking about with automation, that a lot of where we see DevSecOps going is being able to take the guesswork out of decision making. That is really where what comes back to what we see developing with AI, or what we see developing in how vendors across are tailoring their individual solution to be able to quickly ascertain that data and work within the environment to be able to ultimately take the guesswork out. I think that's going to be a huge trend that we continue to see going forward, and how even what we see across the industry as standardized scanning tools are going to have to adapt and evolve with as a growing customer need that you're going to have to be able to develop code faster and be able to have your security apparatus keep up.
All right. Jack, you want to jump in there? Is there some way to think about automation?
My answer is automate as much as you can. Scan as often as you can. And if it's done right, it's not going to annoy the developer. If the scan only tells the developer about the developer's recent changes, not showing, once again, the whole laundry list, then the developer is not going to be annoyed. Many of our customers choose to scan on every commit, because that's sort of as the right shift left point.
All right. So scanning should be like voting in old Chicago. Everybody do it multiple times. As we look at the job function here, and maybe Sid, I will throw this your way. One of our questions is, so is this new security engineering position going to be one of the most sought after in DevOps? And is that going to be a high paying job? And is this something you think that a lot of people will be shifting their resumes towards, presenting themselves as?
Absolutely. I think the future is very bright, because the security engineer, has to understand the developer's point of view, which means that they're most likely ex-developers themselves. But through just, working in particular domains and, learning all the tooling and technology and certifications and so on, they have mastered the art of how do we create these, these golden paths to production, right? These templates that you talked about with the least friction, so that my organization can actually make the most value, I would say, most precious asset in such a way, which is the developer capacity, completely pointed towards business value creation, and not get stuck because of, these, infinite security challenges that are there in this, the 4-layer. And by the way, the layers just keep on increasing. If I add, infrastructure security, cloud security, like if I keep on adding that, it's just going to become too onerous for the developer without the help of that security engineer. So, imagine every 7-8 developers, you need one security engineer inside that team to help them succeed.
Kiran, where do these security engineers come from? Do I just kind of show up one day and anoint myself and say, yep, that's me? Or do we need certificates or training, or how will we recognize security engineers when we need them?
That's a great question. It seems like the last stat that I saw earlier this year, I think, is that there were 1.5 million unfulfilled jobs in the application security, in the cybersecurity space in general. And I think a big chunk of that is in the application security area. However, it's not doom and gloom, because I do believe that a lot of the developers, I believe Sid's earlier point, have somebody who has been a developer, but it has been a security champion within their team, is an ideal candidate for this role. That is for people that are coming in from the dev side of the house. For people that are coming in from the application security or product security side of the house, they're already in the mix. So it's natural for them to get matrixed into the DevSecOps kind of organization. And the third area where people are cultivating these skills is from the DevOps world, where people have been DevOps engineers or SRE type engineers, but it's a natural kind of adjacency for them to get into the security world because they've probably been exposed to some of these tooling before, and obviously these are higher paying jobs, so it just makes sense.
We also have some other questions that I'm just going to randomly pull together, and they go to some of the things we were talking about earlier. But we have one question here where somebody wants to know, can I just scan for the code that's changed since the last time it was committed, or do I wind up having to scan everything over and over again? Anybody want to, Jack, Natasha, you want to take a crack?
The answer to that is yes. Products will vary, but some of them do allow you to just scan on the differential, just what's changed.
All right, that's good. Next question is, how manual, and I guess, Sid, this will come to you, but can I automate this thing end to end? Like no manual steps, no configurations, no custom scripts, or is that, a dream too far at the moment? But, because over time what happens is the more manual things become, the heavier the weight is, the more toil there is, until eventually you decide, I don't want to do this anymore.
Oh, absolutely. We're already seeing customers with zero manual steps in their golden path to prod, with security scanning, SBOM generation, SBOM enforcement starting to baked in. Now, we should always have exceptions, right? You will need, when things are not with policy, you want them to get flagged. You want somebody with higher level of knowledge to come in and help out the team. What is the risk of this? And if we allow an exemption, what is the purview of that exemption? What is the scope of that exemption? How soon can we come back to fix it? So, if a team is following all the good things, all the right things, their golden path to prod is blazing fast. But if a team is not, then you want to be able to intervene and coach them.
A wise man once said, if you have more exceptions than rules, the thing is broken, right?
Yes.
All right. We have a lot of questions that all seem to come down to the same thing. So I'm just going to jump right into it and we'll go round robin on this one. But everybody's like, what's your best advice for getting started, especially if they have a lot of open source components? Where to begin? What's the one thing that you guys know today that you wish you knew a year ago, 2 years ago, that would have made your life easier before you got started down this path? We'll start with Natasha. What do you think?
Well, as we touched on a little bit earlier, certainly if you're not using any AppSec testing today, I think an IDE-based solution is a great starting point, something that will integrate a certain level of both static and software composition analysis testing in there to start wrapping your arms around what exactly are certain open source or proprietary code flaws that I have. But I think on a larger level, what a lot of the comments in today's panel are getting to is that in order to get your start, it's important to know where you're at. Being able to have that visibility across tooling, processes, and people is a very important component to think about as you start your DevSecOps journey. And one thing that I think is really helpful here is to take an approach where you're able to swiftly integrate all of your tooling across different pipelines or developer tools, by having a way to synchronize all of that data, correlate it, and being able to have a single point of interaction between your development team and the tool and interface that they're using to glean their most critical work. I would say that that is probably very core to making sure that your DevSecOps initiatives actually succeed, and being able to mature in that as you climb your maturity model into that, up that security stairwell into where your processes are managed and they're optimized.
All right, Jack, you want to jump in here?
Yeah, I agree. It's a combination of people, processes, and tooling. Tooling is kind of the easiest. One of the analysts at Gartner said earlier this year that software composition analysis is the easiest and most impactful tool that you can add to your application security program to get a handle, an inventory of your open source software. And then a culture shift, setting the right kind of training and partnership between the security team and the developers is real important. We have a few blogs on our website about doing that and planning and how you're going to inject lunch and learns or whatever technique you're going to use to help the developers be comfortable in the tooling that you've given them so that they actually use it.
All right. Sid, thoughts? What do you say?
Yeah. So on the known vulnerability management side, we see that you can start with SaaS tooling, SCA tooling, container image scanning, or DAS tooling. I think you should pick, ideally you should be doing all four because anything can happen. So, but pick one of them, get going. That's number one. And then on the unknown, risk management side, which is where open source component and SBOMs come in, pick something like a Salsa framework that Google has introduced, and pick like Salsa level 2 or level 3, and start following the processes associated with those. All of these, you can start I would say today with open source tooling already out there, you can start very easily with many of these. And then as you try to graduate to the next level, you can put in more, make this more comprehensive, and you can grow on this side as well, on the unknown side. And you'll see that as you get these quick wins and then you are going to graduate to the next level, the collaboration between the three personas, developers, DevOps, and security also is gradually increasing because they all feel that they are helping each other succeed.
Kieran, you have the tough slot because you have to say something intelligent here without saying I agree with everybody else who just went before me.
Yeah, let me see if I can do justice to that. Actually, the way that I think I would advise DevOps teams that are trying to incorporate security is the following. First of all, try to understand why is it that you want to do DevSecOps, and what do you need to do to make your program successful. So the KPIs for defining this, the KPIs that I would go after are, at the end of the day, three things. Am I shipping the most secure product with the least possible friction for my developers and the lowest amount of time and money spent on this effort, right? So if you can measure those three things, the first one, am I shipping the most secure product? There, I think the answer is different for different teams, because if I'm building a traditional monolithic .NET application running on Windows, the tooling that I use is very different from if I'm shipping a modern microservices application running on Kubernetes. So pick the tool choice that makes sense for you. Number two is developer friction. The best way to get past developer friction is make sure that you tell the security results early by integrating into the right parts of your pipeline. And when I say integrate into the pipeline, it's not just a matter of, don't just think I want to do just the build time scanning. I think you've got to take a step back and say, I want to put something in the IDE, I want to put something at build time, and I want to put something at runtime. That gives me the complete kind of touch points to make sure that I'm touching my developers all the time, and every stage that my application is going through and getting promoted to the next stage, I'm actually checking and telling if there's any security issues. That will reduce the amount of friction for your devs. And the third part is the lowest cost and the lowest amount of time and energy spent. look for unified tools, tools that are integrated, that provide more than just one thing, like more than just SCA or more than just SBOM. If you have tooling that provides you SCA, SBOM, DAS, runtime, SAST, whatever, in an integrated kind of offering, that actually saves you a lot of time and effort spent.
All right, guys, I promised you the time would fly by, and it surely has. So Cody, take us away and take us home.
Thank you, Mike, and thank you to Natasha, Sid, Jack, and Kieran for joining us as well. I would like to remind our audience that this session was recorded, so maybe you'd like to rewatch or share with a friend with this amazing conversation we just had. You'll receive an email with a link to access that recording on demand, or you can find it living on the Security Boulevard website at securityboulevard.com/webinars. So we do still have those 4 $25 Amazon gift cards to give away. And our winners are Kandaya N, Fabrice K, Jim F, and Robin V. So congratulations to our 4 winners. Keep an eye on your email to claim that gift card. But if you don't happen to see that email in your inbox, do please check your spam folder. And so to everyone who joined us today, we really appreciate you spending time with us the last 60 minutes. We value your time, and we also value your feedback. So we will be popping up a survey on your screen as soon as we close out. We'd really like your participation there. Just let us know how we can improve on our programs or what you'd like to see in upcoming webinars. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day and have a great weekend. Thanks everyone on our panel for being here once more.
Thank you, guys.
Thank you, everybody.
Thank you.